Problem 9-101. Do you think that you can decide by looking at a number whether a number is rational or irrational? You will explore this idea in parts A through D below. Part A, without doing any calculations, which of the numbers below do you think are rational numbers? Which do you think are irrational numbers? Discuss this with your team and make predictions. So at this point, if you have not already made predictions about each number listed, you want to go ahead and pause the video and make your own predictions just based on what you know about numbers and number sense. And you are going to list for each of these 8 numbers whether you think it is rational or irrational. Okay, and after you've done that, make sure you come back. So what we're going to do is you're going to make your predictions for part A. Now for part B, this is where we actually put the numbers into the calculator. So let's go ahead and have a look at -5/9. So -5/9, if you put that into your calculator, what you're going to get is you are going to get 0.5 repeating. So it's just going to be 0.55555 until your calculator screen can't fit anymore. So remember now that repeating decimals, those are considered rational. So this -5/9 is going to be rational. Okay, our next one is the square root of 7. So you can go ahead and put that into your calculator. We're just going to do the square root of 7. And the decimal equivalent is 2.645751311. And at that point, well, that's where my calculator screen maxes out as far as digits goes. But if we look at these digits that come after the decimal point, you'll notice that there's no pattern, there's no repeats. So this is an example of an irrational number. All right, moving along to the next one, 21/4, or 21/4. Go ahead and remember 21/4 is the same as 21 divided by 4. So to find the decimal equivalent, we're going to do 21 divided by 4. And when you put that into your calculator, you should get 5 and 25/100ths. And because this decimal terminates or it ends after the 5, this would be considered a rational number. Okay, after that we have the negative square root of 15. And once you put that into your calculator, you are going to get a number out for your decimal equivalent. It's going to be, I should actually change this to an equals about sign, so it'll be about 3.87283346. That is where my calculator screen maxes out of digits. So if we look at these numbers that come after the decimal point, you'll notice again that we don't have any real pattern here. Nothing is repeating, so this is an irrational number. And I'm actually going to go back to this the square root of 7 and change that to an equals approximately sign since it's not exact. Our next number that we are given is pi squared. So pi squared, once you put that into your calculator, you are going to get a number that is approximately 9.869604401. And we know that pi itself is irrational. So if we square it, let's look at our numbers after the decimal. I don't notice anything repeating, and it does not terminate. However, that 1 that you see right here, that is where my calculator screen maxes out. I can't put any more digits in. So this one is going to be irrational. All right, the next number we are given is the negative square root of 76. And go ahead and put that into your calculator. When you do, you are going to get approximately 8.7177978887. And again, there is nothing repeating here. I don't see any pattern, so this is an example of an irrational number. Okay, the next one we have is, so our next one is 730 99. And if we put that into our calculator, we can do 730 divided by 99, because remember that fraction bar means the same as divide. And you'll notice that we get 7.37 repeating. Now, since this is a repeating decimal, this is an example of a rational number. All right, and the final number that we are given is in scientific notation, and it's negative 6.4 times 10 to the negative second. So if we convert this really quick to standard notation, that means we move that decimal 2 places over, put a 0 in that valley, so that means that the decimal equivalent here is 0.064, and that number does terminate, so it ends after the 4 right here. It does not go on forever, so this is a rational number. All right, now that is part B. So part C, we've done part A was your predictions, part B we just did. Part C, what do you notice about the decimal forms of rational numbers compared to irrational numbers? So something that I notice is, something that I noticed as we were going along was that the rational numbers, those numbers have equivalent decimals that repeat or terminate. So you want to make sure you write this down. Rational numbers have equivalent decimals that repeat or terminate. And remember, terminate means end. And the decimal equivalents of irrational numbers do not repeat or terminate. So you probably know that pi is the most famous example of an irrational number because it goes on forever after the decimal. It just continues infinitely. Now part D. Is the square root of 42.25 rational or irrational? Explain your answer. All right, so we're looking for the square root of 42.25. And if you put that into your calculator, you'll see that the decimal equivalent is 6.5. So I noticed that it ends after the 0.5. There's no more digits that come after the 5. So 6.5 is a terminating decimal. So that is, it ends after the 5. So in this case, this would be a terminating decimal, which means that it is a rational number. Okay, and that is all for problem 4-101.